Welcome to our community stream for October. In case you can't tell, today is Halloween for those of us who participate in it. And so I think this stream will be especially fun, but we did move it up 2 hours early so that some folks can take part in the festivities. So with that, we've got a pretty cool agenda today. We're going to get an update on a working group within the SIG guest languages from Joe. We'll talk about a little bit about WASI.2, WASM time updates, and then I'll do a round of some event callouts. So Joe, you're up first. I'm going to drop the rest of us, but I want to say first that all of us are here live. So if you have any questions, please ask them. You can ask them over in the Zulip community stream, in the YouTube chat, and every single one of us are happy to hop in and answer questions. So we're gonna hide.
All right.
And Joe, you are up. Not me.
Great. Hey everyone, I just want to give you a quick update to the Golang subgroup. My name is Joe. I am a software engineer from Microsoft, and Phil and I are co-chairs or organizers of this subgroup. We formed this subgroup about 2 months ago, and with a major goal of making WASM components feel native to the Go ecosystem. And that what that means is we want to identify and find common patterns for a bunch of issues that Go developer run into when they work with WASM components. We want to also develop toolchains and compilers that can that fit into the ecosystem that and make it very easy to generate Go bindings to compile to WASM components. I want to shout out to the Go 1.21 work that's done by the special interest group for WASM, and they added WASI Preview 1 support into Go 1.21. And if you're interested, please check out this Go blog post, WASI support in Go. And if you want to get involved, join the #WebAssembly channel on the Gopher Slack. And I want to give you a very short demo of Go 1.21 support for WASI. Going to share my screen. I did not turn on the permissions for Chrome to share my screen.
Hey Joe, I can talk about a few things, and then you can work on that if you want to rejoin and do the reshare shuffle. Okay. So I'm gonna bring up a project that Randy created, and I see that Randy's here with us live. So hey Randy, hope you're doing good. He has been doing a lot of work on creating basically Go native tooling for Go within this working group. I think that's especially desirable because the ergonomics right now are, I guess I would describe them as a little rusty, as in very Rust-centric, and not quite what you would expect with idiomatic Go. And we have a requirement right now on building with Seago. Joe might correct me that might be gone soon, but today that's the case with WIT bindgen. And so, Go developers usually don't care for that. And they definitely want to be able to contribute and build their own language bindings, and they want to write that in their own language. And so a lot of the work that's happening right now is towards being able to write in Go, building language bindings, building a system that fits within the Golang ecosystem. So I think all of that work is incredibly exciting. And that's really a lot of the purpose of SIG guest languages as a whole. Go is one of the many working groups that are in there. There's another one for Python. There's a new one for .NET and C#. I believe we're also spinning up a new C++ one. So if you're interested and passionate about a specific area and languages, and you want to help us build more tools and different parts of those ecosystems and finding ways to integrate it within the component model, please join. Joe, any luck or?
No, I probably have to restart Chrome to be able to grant permissions. But at this stage, I'll just skip the demo. But the demo is primarily I wanted to show that how you can write a Go program compiled to Wasm with WASI Preview 1, and that prints hello world. But you can find the demo actually in this blog post. So just if you follow this and read that, you will be able to know how to do that.
And that blog post specifically is the WASI support and Go blog post for Go 121?
Exactly.
Got it.
Right.
Yep. I posted a link to that, and then I also dropped in a links to the WASM Tools Go that I mentioned that Randy in Randy's personal GitHub org. Now, I haven't talked through any of the current work stuff yet, if you want to take off from there.
Great. So following Go 1.21 and that supports WASI Preview 1, we are primarily focusing on discussing how we can support WASI Preview 2 that's coming for the future versions of Golang. And one major requirement for WASI Preview 2 is to be able to support the WASM components. And so we have some current work. Ashil has done some research on how we can map Go memory management in the WASM component model, because the components has a specified canonical ABI realloc function, and we want to figure out how we can write that in the Go compiler. And Shil also has a proposal to add the Go WASM export directory, and so that a Go program can, when they compile to a WASM module, we can export functions. And I personally am working on the Bitbangin repo to add resources for the current Go Bangin. And this work was 100% written in Rust. And as Bailey just mentioned, we also have Randy working on a pure Go implementation of the Bitbangin and WASM tools. So that's everything we're doing today. And we have very exciting things to share in the future. All right, so if you want to join this subgroup, we meet every other Tuesday at 10 a.m. PST. And if you want to get invited, please email either my email address or Ashil's email address. And we also have an agenda for every meeting. And that's it for me.
Awesome. Thank you, Joe. Encourage folks to please ask questions. Joe's going to stick around. And I think there's a lot happening in the space, so please keep an eye on it. Thank you, Joe. I hope y'all are ready for Pat. Hi, Pat. How are you?
Hi. Happy Halloween.
Happy Halloween. We're going to first start with WASI. I'm calling it .2. I don't know. What would you call it? What are you calling it right now?
Preview 2. So, I mean, the marketing name, I don't know. The marketing name has always been Preview 2, right? That's what we've been saying for years and years. The previous thing was called Preview 1. But now we actually have version numbers in the WIT files that define what the standard is. That's something we didn't really have before. We just kind of stuck the word Preview 1 in a bunch of string positions in the old WIT-X. But now there's an actual like semver version in WIT. And so when we release this, we're going to call it 0.2.0. We've never released an 0.10 in the WIT format because that was back in the WIT-X days. But this will be 0.0, which kind of means like, you know, we're not going to do a breaking change until it's 0.30. But we might add non-breaking changes in 0.21 and 0.22 and so on. So that's what that's trying to communicate with our new versioning.
Cool. Yeah, I wanted to call out that there are only a few WASI subgroup meetings until the new year. So the next one that's going to be happening is November 2nd, which is this week, this Thursday. One thing that I'm particularly excited about is changing what we had WASI stand for. This actually came out of a conversation that I had with Oscar Spencer in Barcelona. We were eating breakfast in the hotel buffet area, and he had this idea of, you know, it really doesn't make sense to call WebAssembly system interfaces with what we're doing currently, and it's kind of confusing for people. But really what it is WebAssembly standard interfaces, and you don't really need to change WASI if you have it represent this instead. And so we'll be taking a poll on that on this Thursday. Also, the other thing that I wanted to give a shout out for is that we have 2 worlds, and they're both at phase 2. But Pat, do you want to talk through what it's going to take to be a part of phase 3?
Yeah. So something we have over in WASI that we voted on what our process is just a little while ago. I think back in September or maybe August. Is we have this phase process, and we've designed it so like it reflects what the WebAssembly community group does for their proposal phase processes, but there's tweaks to make it applicable to WASI, because they're not really a one-to-one correspondence in precisely the way we're going about things, and we think that's fine. So right now, phase 2 basically means that what you've done is you've defined your compatibility criteria, which is to say that this is, we have compatibility of multiple implementations of this this proposal, this interface. What does that actually mean? And so, like for WASI CLI, it's like, well, it better work on Windows and Mac and Linux. For the WASI HTTP proxy, it says, yes, it should work on Windows, Mac, and Linux. And also, you should be able to use the outbound HTTP request interface using WHATWG fetch, the web API. We said, oh, we're going to add an extra piece to the compatibility story, because we really want WASI HTTP to be something that you can use both in a standalone WebAssembly implementation and on the web in the browser, or also in places like Node.js.
And really, that's not too different from what the CG does, where usually it's a requirement around multiple web VMs having implemented that standard
yeah, exactly.
specification.
I mean, one thing that's different about WASI is, well, we weren't primarily concerned with web VMs at all. And for a while it was just non-web VMs, and then there was like, there's a JavaScript polyfill, but does it really do all the things you would expect? Not really. We're taking that a lot more seriously now. We want this to work on the web, because the component model really makes that possible to do in a really useful way. Prior it was you'd basically have to ship a whole JavaScript implementation of how everything in WASI works, whereas now with components, it's like, well, if you want to provide a file system on the web, you could ship using WASI-Virt, a read-only file system, as a regular WASM module, and you don't have to worry about your web browser having local file access. Of course, if your web browser does have local file access, you could provide an implementation that does that as well. So it's a lot more flexible now that we have the component model. So it's a lot more useful to be able to say, yeah, we really want to be able to do WASI things on the web.
And so basically, to consider Preview 2 launched, so to speak, our launch criteria for Preview 2 is having these 2 world definitions, or any world definition technically, that has reached phase 3, and we have 2 of them. And then that also means that we also have 2 implementations. We're expecting it to be basically Wasmtime and Jco, and that's really well represented in this project board. I took a screenshot of this right before this call, and you can kind of see exactly where all the action is at, basically, where a lot of this work is going into implementations inside Jco, implementations of making WASI HTTP work well and fit well with like the fetch API for web. And then there's also still some ongoing work for WASI sockets within Wasmtime and some other places. Do you think this snapshot here, Pat, fairly well captures what's remaining as far as implementations are concerned?
Yeah. So yeah, that snapshot is kind of how I accidentally became a Bytecode Alliance project manager, a job that we didn't even know we needed. So we're kind of tracking, and we have these periodic meetings inside the Bytecode Alliance called component model implementers. And then we, of course, also have our own stand-ups and so on. So we kind of keep a track of what of these tasks are in progress and who is working on them, to divide up the work, that there's some stuff that's being worked on in Jco. There's some stuff that's being worked on in Wasmtime. There's some stuff that's this componentized JS stuff. Actually, that's a really cool piece of our puzzle right now that I'm really excited about, which is there is a really good set of tests out there for HTTP called the Web Platform Tests. They made a really comprehensive set of tests that really reflect how the web works as part of specifying what WIG fetch. So we want our implementation to be able to pass those, but of course those are all done in terms of a JavaScript API, not a WASI API. So it's like, well, how do we show that we're doing all the things that JavaScript API is capable of and doing them in the way it expects errors and stuff. So Componentized JS is the Bytecode Alliance's effort to, we're using SpiderMonkey compiled to WASM, and the event loop there is we're in the process of reframing it to work on Preview 2 poll. It previously was built on top of Preview 1. So changing it to work on Preview 2 is kind of an architectural change. And then, of course, the fetch and JavaScript land there, and all of its related pieces will hook up to HTTP. That's item number 37 on the list, or issue 51. And once we have those pieces, then we can take some existing work we've done to make web platform tests work in some other contexts, and we can run the web platform tests and test both the JCO implementation, which is basically fetch on top of WASI HTTP on top of fetch, and make sure all of that works. And then, of course, the WASMTime implementation is like fetch on top of WASI HTTP on top of WASMTime's HTTP implementation, which is based on Hyper. So that will really show we're passing this existing test suite that's really comprehensive, and that should show a lot of confidence in it. So that's just one window into what's going on there. There are a lot of other pieces of the puzzle moving, but a lot of them at this point, we're getting near the end. We're heading towards stability in a lot of these specs, and it's yeah, some of the implementation work is going to catch up, but the spec itself, at least in WASMTime, we're nearly done implementing.
And that's a good jumping off point. So as you can see, there's a lot of work happening for the web side, Node.js side, and a lot of that happening under the banner of JCO and componentized JS. But we also need the reference implementation within WASMTime to be complete as far as implementation is concerned. So Pat, I'm hoping you can give us an overview of what we're talking about when we talk about WASMTime v14 and v15.
Okay.
I call some things up, but you can tell that I meant to finish that bullet and I didn't.
Oh, that's all right. I think you got the big one. So WASMTime 14 is out now. We released that a couple of days ago, a week ago. I don't know. Anyway, it's out now. You can use it. We made some changes to the WASI HTTP implementation that finally all got shipped in WASMTime 14. So that was both the way we specify WASI HTTP. We had to do this big lift of changing it over to be done in terms of resources. And we also made it work with streams properly. So essentially, Trevor and I did a rewrite of a lot of the WASI HTTP implementation for a couple of weeks. That shipped in 14. And one of the big pieces that unlocked was this inbound request support. So for a while, WASI HTTP worked in a limited way of being able to do outbound requests in a WASMTime implementation, which is very useful for proving out that certain pieces of the puzzle worked. It was a great stepping stone. But you can't now with inbound requests. What that means is you can use WASMTime as an HTTP server. So it's just open it up on a port with this new WASMTime serve subcommand, which the command of the WASMTime CLI, and it'll tell you I'm going to respond to HTTP requests, and you can send them. So I can do a demo of that in a minute, but I'll finish talking through the rest of these. The IP name lookup stuff, so that's over in sockets. The initial implementation there didn't have DNS integrated yet. It was just you tell me the IP address of a socket, I can open it up. So they got to implementing IP name lookup, DNS, a very basic interface to DNS that doesn't open the big can of worms of all the really hard and challenging parts of DNS yet, which I'm sure we'll tackle one day, but not right now. Simple first. So that sockets IP name lookup is a simple thing that's done first. And then finally, the CLI interface has changed in WASMTime 14. I think the new CLI interface it's designed way better. The old CLI interface to Wasmtime just sort of like accrued stuff over time, over many years. And that was okay, but it was getting really long in the tooth and looking at adding support for a lot of this new component model stuff and just kind of like it needed a comprehensive look at the design. And so Alex led an effort with many others contributing as to what that new design should be and implemented it. And it shipped. And what we didn't ship was compatibility with the old one. And that correctly, I think, made some users downstream a bit disappointed. So we've done patch releases where now it'll work the old way, it'll work the new way, and at some point we're going to turn the old way off. You can go and read the whole thing in that issue 7384. There's been a couple of patch releases just to fix little bits and pieces of that since the big, we're going to make a backwards compatibility mode thing shipped. So yeah, I think that's that.
I think that's a good coverage. I didn't really add too much to Wasmtime 15, but do you want to show off Wasmtime 14 first before we?
Yeah, why don't I do that? So, my colleague Dan, who you probably all know of, sorry, I'm trying to exit full screen here. I'm just trying. Sorry, I don't know how to use this thing. I want to screen share. I got it.
It's a trick or treat game, obviously.
Yeah.
I think.
Okay, so now my screen is sharing somewhere, and Bailey as the director. Okay, and obviously my font size is not anywhere near right. Okay, so my colleague Dan, Sunfish Code Hello WASI HTTP. So he made this nice GitHub repo. And this was the idea is like there are unit tests in the Wasmtime tree that make all this work, but no one wants to like read our unit tests to figure out how it works. So Dan just wrote a nice demo of it. And so you can clone this repo, and he's got nice instructions of how to install the things and then an explanation of things. And I'm not going to read all this text to you. I think you should go and read it because Dan did a really nice job. I have cloned it here. So to build it, we use cargo component build. I've already done it, so you don't get to see it actually do anything. Cargo component is a tool by Peter Hewen and many others that builds your Rust projects as components, and so it hides a lot of the complexity of building a component and generating the interfaces for the component and so on. So you just use that cargo component build, and the thing that pops out is a component. But what are we building? Let's look at the library code. So the thing we're building is, we're calling this cargo component bindings generate. And what this is saying is in the, hello WASI HTTP. In the cargo toml here, we're specifying the dependency packages here of what WASI HTTP is and the other bits and pieces of this puzzle. So it's like, yeah, we're specifying what those dependencies are. And then if I need bindings to talk to anything that's a dependency of this project, it just generates them. So now it's created a module called bindings. And then, inside there's all the WASI HTTP bits. There's also other bits. And I can use those as Rust. And now you might say, yeah, but I can't see the code that this generates. What you can do, first off, Peter is working on a way that you can see it. Your editor will know to autocomplete it. It'll work well with Rust Analyzer. That's in the works. We kind of know that doesn't work right this moment. He might have already merged it in main and this demo is not caught up yet, but at any rate, what I've been doing for years is just using cargo doc or Rust doc. So if you run cargo doc, and in this case, we're going to pass the document private items flag because those bindings are private to this source lib. What it's going to do is generate a Rust docs over here And so this has a little lock icon on it because that's a private module. So now if we go into the bindings, we go into WASI, and here's all of those WASI proposals or WASI packages that it built. So if you were to look at stream, pullable is in here, so when you use things like that, it all just works out. But of course, the interesting thing here for this program is okay, sorry, I've put too many things on the screen. Is we have this incoming request, right? And it's like, well, what's inside an incoming request? I click here, and it's like, oh, well, I've got a thing for getting the method out of it. And what's a method? It's one of these. Great, that all looks like HTTP, right? You get out the path with the query, you get out the scheme, and so on. So all of this code that does this bindings is generated by this macro. And to see what the interface looks like, you could, of course, if you want to, you can go to the WIT files for WASI HTTP and then guess at how did this get turned into idiomatic Rust code. But you don't have to guess. Nobody likes to guess. So use the Rust docs. Other integration with the editors is coming soon.
Pat?
Yeah.
I've literally just been guessing. This is like this is the coolest pro tip that I've ever seen on
I guess
live.
I should have been telling people about this for a while. But
this is awesome.
There wasn't a whole lot of us writing these programs for a while because they weren't really ready for other people to be writing. Now we're getting there. We're very, very close to there. When we release Preview 2, then you'll really be able to write a program with this and it'll actually run on things for a long time. It'll be stable. If today you don't like what WASI HTTP looks like, wait a day, we're going to change it. We're getting in little changes of the last little fixes we want to do pretty constantly right now. But we're going to settle all that down and be stable real soon.
Great.
So play with this demo from Dan. It's really cool. Play with this API. There's lots of really great, I sincerely believe we've done HTTP right. We have had a lot of experts work on WASI HTTP. People at Fastly who have a lot of experience running really big websites and doing CDN stuff. Peter Sikora from formerly of the Envoy team. He was the person who put WebAssembly into Envoy, the proxy WASM proposal. He's made a lot of really great contributions to this. Our friends at Microsoft have made great contributions to this. So yeah, I think a lot of people who really know what they're doing have put a lot of energy into this API, and I personally am really pleased with how it turned out. So thank you to everyone who's been contributing to this. And I'm glad we finally have some, look how nice this looks. These are all they didn't look like this just a couple months ago or a month ago before we had the resources support. We're these are all methods now. Outgoing body finish is a, you have all of these in an impl here. They used to all be freestanding functions because the actual thing was just a U32 because we hadn't implemented resources yet. Now that's all done. That's behind us. If you don't know what any of that means, good. You don't have to. I'm glad you don't have to worry about it. Really happy about how this turned out and looks nice to write Rust code for. Of course, if you want to write code in other languages, all of that support is coming soon. Our friends at Fermyon are working on it in JS and so on everywhere else. That the stuff in JS was actually on that last project page. That was stuff Till was working on. I'm going to stop talking about this. We should move on to the next topic, right?
Yeah, okay, but I really enjoyed the excitement. It was a really cool demo. So thank you, Pat, and vicariously through Dan Goman. That was really good. And yeah, so let's that was Wasm Time 14. That runs today. It's released. You can use it. So let's talk about the next release.
Okay, Wasm Time 15. It's going to come out on November 20th. We releases come out on the 20th. That's how you remember it.
Although I believe we were talking about maybe delaying that one since it's the week of Thanksgiving in the US.
Actually,
so we were thinking about maybe doing the following Monday, but
yeah, that's a good idea. Because all the release stuff is really good. It happens with automation. Like somebody doesn't push a button to make a release. It's just like when a cron job goes off in GitHub, it makes the release. And that's actually really empowering because it means that we don't need to make it one person's job to do that. And it really importantly, it means that there's not a person you can go and nag and say, wait, can you hold off on doing the release until I have this thing merged? It's like, no, it's all automatic. You got to make the deadline. So it's actually really good that we haven't put a person in the way there. But anyway, we'll modify the date for Wasmtime 15. Sure. It's going to come out the end of November. And our big goal for Wasmtime 15 is we are going for stability of the WIT definitions. So to date, it's like we've been figuring out what WASI is and how it works and making all these little tweaks as we actually implement it. Like, you can write a spec down, but until you've implemented the spec, it's not done. But we've done a really good job with the implementation. And so we are trying to now say Wasmtime is stable with respect to these WIT definitions. And so we're going to put all the WIT definitions up, and we're going to synchronize WASI, the WebAssembly/WASI dash proposal name repos, right? That's the canonical place where WASI lives. That belongs to the W3C. But over in Wasmtime, we have copies of all those files. And of course, then in Wasmtime, we make little tweaks, we see how it works, and then we say, yeah, okay, now we'll make a PR to put that up in the spec. We're going to keep them matching. And so we're going to make a release candidate version upstream in the W3C stuff. And Wasmtime is going to ship that in 15. And we're going to do everything we can to not break them. We can't promise you we're not going to break them, but we're going to take it really seriously. The reason we can't promise you is because, the real promise of not breaking them is we're going to have a vote in the W3C to say this is preview 2. And that's something that all of our collaborators get to participate in. And of course, the big thing for that vote is that 2 implementations are done. And we've been saying Wasmtime's 1, Jayco is the 2nd. So our friends at Jayco are still working. They're going to wrap up their work. We're thinking right now they're going to wrap it up in January. And then they'll be able to show, okay, this is now is a 2nd implementation of the exact same interface. It passes exact same tests. So we have 2 compatible implementations. We're really proud of that. And then we'll be able to do a vote that I expect will be successful. So yeah, so that's our goal with Wasmtime 15 is we're gonna say we really hope that these WITs turn out to be preview 2. As we get feedback from the Jayco people, maybe we will have to make a change to the WIT. Or if we implement web platform tests and web platform tests find something in our HTTP implementation that we never thought of because we're just human, then perhaps we'll have to do something there. But I'm very pessimistic. I think this is still going to work out. So let's hope that this is stable. Yeah.
Yeah, and like you said, by forcing Wasmtime at least to point to the upstream WIT definitions, upstream being what's from W3C, we know that we'll have a level of stability through January while Jayco is working on implementation. And if there is something that we have to change, we know that it was real, and that's also why we have that 2 implementation requirement, so that we can catch those kinds of things and not try to retroactively fix stuff that really has to be fixed. So yeah, exactly. I'm super excited.
Yeah, like that's something we're really proud of in this standard. This is the 2 implementation rule we think really makes a difference in terms of how well something was thought through, and will other people be able to go and implement it. And so, our friends over at Wasm Edge are talking about, they have all of their stuff laid out. That was actually at the last WebAssembly meeting. Michael from Wasm Edge came and talked to us about his team's plans for implementing WASI Preview 2. And that's awesome. We really want them to be successful. We don't want to hand them something that's only ever been implemented on Wasmtime and say, good luck. We want to say, well, we did it in Wasmtime, and we also did it in this very different environment, Jayco. And so we think probably a 3rd should work. Now, of course, if they find real big problems, we'll come up with the ways to deal with those as we get there. But, I have a lot of confidence based on what the Jayco team is doing so far, that they are finding the hard parts of this to do right. And they're very similar to the parts that were hard when we did them. And so I think if they get through those hard parts, the rest is all going to work out. That's my thinking.
All right. I'm really glad you didn't balk at this last point that I threw in there at the end. I was like, you know what?
Oh.
Shoot our shot. I think we'll say we're done. What do you think?
Yeah.
All right.
Yeah,
cool.
I mean, that's our goal. That's our goal, is to be done. There's a couple things in WASI sockets. I was just talking to Dave Baker today. He's been doing all the really great work on WASI sockets lately, where he's like, I think we're just going to trim one or two little things out of the spec. They're like, oh, those are hard problems. We'll work on those later. But the core of it is done. So that's one of our issues we're tracking, is like, we'll do some little fixes there on what's specified and what's implemented, and then we'll say, this is WASI sockets, it's done for now. We'll still consider making additions later to these things and breaking changes in preview 3, but for now, the interface is complete.
That's huge. So kudos to you and the entire Bytecode Alliance org. I would say that we probably had 40 plus contributors that are part of this, so I can't enumerate all the names, but yeah.
Yeah, that's actually
huge.
a really wonderful thing, is how many people are involved. Like all year, new people have been getting involved and making great contributions. And there's now, sometimes there's more people contributing than I can even keep track of, which is a really cool and also a little bit scary feeling. Mostly cool though.
Awesome. Well, thank you so much for giving an update on that, Pat. And I think Joe is ready to show off his demos, which I want to end on that. So thank you, Pat, and welcome back, Joe. I'm gonna shuffle people around, and your screen's up, and I'm gone. Hey, Joe, we can't hear you.
Can you hear me okay?
Oh, I can hear you now. Yeah, okay, go for it.
All right. Apologize for not being able to show the demo due to a permission issue, and I have fixed it. So allow me to give another try of the demo. What I want to show you is how you can write a Go program for today, and you can compile that to WASI Preview 1. So what I have here is a Go compiler. Version is 1.21.1, and I have a very simple main.go file that just simply prints hello world. If you run this with the native binary, it will see hello world, obviously. But you can specify the Go operating system to be WASI Preview 1 and the Go architecture to be WASM. Well, those two flags are pronounced as Goose and Gork. And then you build the same main.go file and output that into a main.wasm file. What you get is actually a wasm file now. And you can run this in any WASI supported WASM runtime. And by default, I'm using the WASM time runtime here. And you see the same hello world. And then I want to show you one major limitation of this WASI support in Go 1.21, which is due to the limitation of WASI Preview 1 that doesn't have the network socket support. So now let's take a look at another file called dns.go. And what I'm trying to do is to do a lookup host on golang.org. If we run this file using the native binary, and it will see the DNS lookup. But if we compile this to WASM, and let me try to compile to the right file and run this, you will not be able to run it because the WASI Preview 1 does not have the socket support. And this is a driving motivation for us to support WASI Preview 2 because it has WASI socket support. As a bonus content, because Bailey and Pat just talked about WASI HTTP, I also want to show you a Go component that uses WASI HTTP. So on the editor on the right side, I have a WASI HTTP guest program written in Go, and that simply has a main function and it's using, it's writing a handle function that taking the root path and return a hello from Wasm. So without further explaining what this, what's the host is doing, let me just show you a quick example. And now I want to run the runtime. And the runtime you're using here is WASI-ROM, and we'll explain what that is. And then, so this is running and it's firing up a HTTP server, listen to port 8080, and I can do a curl of 8080. I don't know if you can see this clearly. Let me just zoom in a little bit, and let's try it again. Hello from Wasm. And so this response was handled by this Go component that prints hello from Wasm. So what this is doing is using the WASI HP server and WASI HP proxy. And those proxy files in the HP module is being generated by the WebBanjo work that I contributed to early this year. And it's taking a WIP file and generate all the Go bindings, and you can import that as a library. And this is exactly what this handle.go is doing, importing the proxy and writing an API for the HP handler. So that's a demo. The runtime I'm using WASI-ROM is from a repo called WASI-Go, which adds the socket support for WASI Preview 1, and underneath is using another Go runtime for Wasm called WASI-0 to actually run this Wasm file. So this is a pretty cool stuff. Right, and that's it for my demo.
This is so cool. Okay, I love it. I'm gonna do like a quick summary for folks at home because we haven't for a really long time in Go. When you were building with Wasm, what you're getting was something that had a bunch of JavaScript glue in it, which means that I had to run it basically in a JavaScript-enabled VM, so probably like Node.js or in a browser. And that was really cool. I think I can think back to like, maybe it was 2017, maybe 2018, when the first time I built with that, and I got a Jupyter notebook building in a little web view. And actually, you know what? Credit goes to Kevin Smith. I think he did it first, but like blew my mind playing around with that. And then, you know, it's still tough when you have a bunch of JavaScript glue in something. It's really hard to separate that out. And so not only do we now have a piece that supports WASI Preview 1, one of the other things that I want to like shout out from like the rooftops, right, which is basically part of your demo, is that we were able to take something that targets WASI Preview 1 and adapt it to work with Preview 2 and with the component model. That's huge, right? So that means that we're not necessarily locked into Go releases to be able to do this type of experimentation. Something else that I was Joe, you might want to talk to is about the differences between TinyGo and Go. Do you mind explaining a little bit of that? I think folks would be interested.
Yes, and the way that I compiled this module is using TinyGo. I didn't show that, but you spotted, Bailey. The difference between TinyGo and Go is Go doesn't really have the Wasm export directory, so it's not able to export Wasm functions. But in the component model, in the WIT file WASI HTTP, we actually need to export a HTTP handler, and this is exactly this proxy Go is doing. So TinyGo has that feature, and this is for one reason we have to use TinyGo to compile this HTTP handler into the Wasm component instead of using the mainline Go compiler. The second reason is Go compiler has a GC built in, but for TinyGo, we can disable the GC. That was the memory management proposal I mentioned at the very beginning that Ashil was working on, is to try to figure out how we can support the canonical ABI realloc function for the mainline Go so that we can swap from TinyGo into Go. So those are the two reasons we need to use TinyGo for this project.
Right, but as you pointed out, there are a number of different work streams that are happening right now for the first time I ever heard this term was in your working group that you co-chair, Big Go, as in upstreaming to the mainline Go project to be able to do all these things that you're showing here. I think eventually people will have options to use Golang upstream or still continue using TinyGo. I think TinyGo is really great for being able to target tiny places, hence the name. But yeah, I think it's really promising, and there's so much stuff happening in that space. And so if you're interested, do join Joe during the Go. Let me pull that back up just because I'm hoping that you just watched that and you thought, oh man, this is awesome. Here's the meeting time. And yeah, thank you so much, Joe, for being able to come in and swing for the fences for that demo. That was awesome.
Thank you so much, Bailey.
If anybody has any questions, please ask them in the chat. And Joe, will you stick around for a few more minutes? I'm going to do a little bit of a wrap up around the event, so you have maybe 5 more minutes to ask Joe or Pat any more questions that you may have. Okay, thank you, Joe. So one last thing, I want to give a shout out to several different events that are happening really, really soon, actually. So this Sunday, there's a KubeCon WASM social event that's going to be hosted by Dan Phillips, and he's hosting it with many of the other WebAssembly community meetups all around the world. I will be there representing the WASM Triangle, which is based in North Carolina, where I live. But I believe the first WASM meetup I ever attended was actually WASM Chicago, ran by Dan. And when I wanted to start a meetup, I sent Dan a note and was like, okay, hey, how do I do this? What's the right way to do it? How do you kick it off and how do you get people interested and excited? And so it's really cool to kind of like come full circle and get to actually go to a real sort of in-person meetup with WASM Chicago. So that is on Sunday. If you happen to be in Chicago at the time, you don't have to have a KubeCon ticket or anything, and the event itself is free. Now, the one that is not free, unless you're speaking, I suppose, is WASM Day and KubeCon / Cloud Native Con. That is next Monday. I put it kind of like underlined and italics, mainly as a reminder for me to get my talk finished with Kate Goldenring. We're kicking things off. And so that's going to be an action-packed day on Monday of all WASM all the time. Then I also highlighted that Tuesday, Wednesday, and Thursday has a good smattering of WebAssembly-centric content. So I think it'll be a really fantastic week next week. If you're not able to make it out to Chicago, or even if you are, do also plan on WASM.io 2024. That's going to be March 14th and 15th in Barcelona. The last event in 2023 was amazing. And so if you're on the fence or you want to figure out or watch some really good talks from last year, do check out their site there. And the CFPs are open. So I really recommend getting one in, and I would love to see you there. So that is me doing a roundup of events. I'm sure there are a lot more happening. It feels like things are accelerating. So yeah, it's going great. It looks like I do see that we've got maybe one question here. Do we know when Go will support WASM GC and the component model, when that will integrate in? So part of one of the earlier links that I dropped in here, maybe it went through. I actually don't see the chat anymore, but I'll link them out from the Google Doc that both Randy and Achille have been working on. But essentially, part of that stack switching piece is part of the Realix story that Joe was hitting on. And Joe, I'm going to pop you in here too so that you can help answer. Is steps in that direction. So I don't expect necessarily WASM GC to be connected for the Go compiler. They're pretty different, but there are other aspects of the WebAssembly specification that I expect it to plug into. I hope that makes sense. Is there a better TLDR for that, Misaka, at all?
So from what I have heard from the Go community regarding to WASM GC is there are some inherent design that makes it very difficult for Go to implement WASM GC. So I won't assume it's going to land in anytime soon.
Right. And so the way that it basically works, if you're using like the demo that Joe you showed off, was it compiles in the garbage collector basically as
Right.
part of that WASM build. So it is slightly larger than say like the equivalent in C or even Rust. But they're still pretty small. Do you mind printing out what you built just a second ago?
It's 2 megabytes. I've checked. Earlier.
Okay, that's not. Listen, when I built with Emscripten and C++ the first time in like 2016, it was not that. It was like 8 megabytes easy. And so, anyways, there are a lot of optimizations we can make. Right now, it's about, I think primarily getting a lot of this working. And so the second half of that question was, when will the component model integrate in with that as well? So the way that I expect WASM GC to interact with the component model is that there is a lot of work happening right now. That was mainly by Ivan, I believe. I'm blanking on his last name, but from VMware, working on adding garbage collection to WASM tools and the WASM time implementations. I believe that work had gotten really far, if not mostly complete. And then there's the second phase that we need to do, which is basically annotating all of the types within within our basically our WIT definition piece to identify what things are shared. And once we have that work, then it would be done. So we don't have an updated roadmap for that yet. The focus obviously has been on launching Preview 2, but I totally expect that to be one of those laser focus things that we work on in 2024. Yeah, and Randy added another note here about how WASM GC would need support for internal pointers. So I understand there's quite a bit there to make that real. So not necessarily yet. Are there any other questions or more details on any of these that folks would like to see? Okay. So Joe, what's next for Go right now is that you're actively working on adding resource support within the Rust WIT-bind piece. And then we're also expecting other changes about how BindGen might actually work for Go, right?
Yeah, so there are 2 major directions we are working on under the subgroup, and one is to figure out how we can support WASI Preview 2 in the runtime or in the Go compiler. And so that means we probably need to be able to compile the standard library of Go runtime into WASI Preview 2 APIs, including sockets. The other direction is what Randy and I and other folks are focusing on is to be able to write the binding generators from WIT packages. And those generated bindings either can be used by your guest programs as a library or can be used in the Go standard library in the runtime.
Very cool and very exciting. And so I understand you have a talk, right, at KubeCon. It's going to be pre-recorded and it'll be up on the KubeCon CNCF YouTube. So I'll probably post some links about that. Or even David Bryant might hook me up too, and we can do it on the Bytecode Alliance Twitter. Because I think we should get folks excited. There's more work we want to do here for sure. I think is the first part I'll add is that there's more work, but there's also something that you can build with now, which is the way that you accelerate all this. So thank you so much for sharing and all the effort. And I think we'll end the stream there. I don't see any more questions. So I hope everybody has a happy Halloween.
Happy Halloween. See you.